focus on, before our exit assessment next week is going to be radicals. This is something that we haven't practiced in class, like the other topics, but it is important because you will definitely see a few of these questions. So when we have these radicals or rationalization problems, we just have to, like always, be careful about what they're asking. They could ask us to just, simplify this radical or rationalize this, and we're going to attack those in two different ways. If we have something like this example on the left, where we have to simplify it, in order to solve this, we have to find the greatest perfect square that's also a factor of 75. And we can realize that, 25 is definitely this greatest factor. That's a perfect square. And 25 times 3 equals 75. Likewise, we can also say that the radical of 25 times the radical of 3 equals the radical of 75. Now, 25 is a perfect square, so taking the radical of 25, that's equal to 5. So 5 rad 3 is the simplified version of radical 75. So this would probably be a multiple choice question that would look like this. Okay? Now, when we have something like this one on the right-hand side, in order to rationalize this, we need to multiply both the numerator and denominator by the value of the denominator, which of course is on the bottom. So we have to take this, and we have to multiply it by rad 3 over rad 3, right? We're basically multiplying it by the number 1. So 7 times rad 3 is just 7 rad 3, and rad 3 times rad 3 would be the radical of 9, which we can simplify this. So the rationalization would look like this. 7 rad 3, radical of 9 is equal to 3, and this is what our answer would look like. Okay, this problem would be a little more advanced or difficult, and involves, little geometry, and we want to know what the perimeter of this square is. And yes, you have to take my word for it. This is a square and not a rectangle. So obviously, all of these sides, should use a different color, all of these sides are equivalent, right, in a square. So if we find one of these, we can easily find, the perimeter. But, so that's our goal. We want to determine the length of each side. Now, if we break this down, we have a right triangle in here. So this problem also involves a little Pythagorean theorem, where a squared plus b squared equals c squared, where I don't know what these sides are. So I have x squared plus x squared equals 1 squared, which of course is 1. So combining x squared and x squared, I'm going to get 2x squared equals 1. Okay, now it gets a little, trickier. Like, this doesn't really make sense. Well, x squared, we divide both sides by 2, is 1 over 2. And now I got to take the square root, right? So I have x equals the square root of 1 over 2. I personally like to write it like this. It just helps me understand it a little more. Oops. Because now what we have to do is rationalize. So like we did in the last problem, and I can simplify this because the square root of 1 is 1. So each side is equal to 1 over the square root of 2, which I don't want that on the bottom. So like we did with the previous page, I'm going to multiply the numerator and the denominator by the value of that denominator. So on the top, I get rad 2, and on the bottom, rad 2 times rad 2 is rad 4, which simplifies to 2. So each side is equal to rad 2 over 2. But now there are 4 of these if we want the perimeter. So I could add them up and say plus, 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 but, it's just easier to multiply it by 4. So 4 times rad 2 over 2. 4 times rad 2 on top. And we can reduce that. 4 over 2. This reduces to 2 rad 2. And that is our answer for the perimeter of this square. Okay, now if you remember from, I think, one of our first exit tickets, one of the very first classes we have together, we investigated what's on the SAT. And the heart of algebra is a major, major topic. So you could see these radicals embedded in algebraic problems. So here we want to know what y is in this equation. So we have radical 3y squared plus 19 minus 5 equals 5. So in order to simplify this or solve this, first thing we want to do is add 5 to both sides. Use a different color. So we're left with the radical of 3y squared plus 19 equals 10. Okay, now what we want to do is we want to square both sides to get rid of this radical. So we're going to, this is cubed, by the way, so 3y cubed. So get rid of that radical by squaring it. 3y cubed plus 19 equals 10 squared, which is 100. Okay, now we are ready to solve for or get the y term by itself. So subtract 19 from both sides. 100 minus 19 is 81. So we're going to get 3y cubed equals 81. Okay, first thing we want to do, divide both sides by 3, get y by itself. Y cubed equals 27. Okay, 3 times 3 is 9, times 3 is 27. So by taking the cube root of each side, we are going to get y equals 3. This could be, a fill-in type question. Okay, it's funny how this class, we work in an order for a reason. So now we're on, radicals, but last week we spent about a week and a half on quadratics, which is a major topic and can be a little tricky. So here we kind of have a combination of both, and it really doesn't look like that at first. So we have x equals 5 rad x minus 6. And we want to know what are the solutions to this equation. Okay, well, this is kind of confusing, right? I'm not really sure what I'm looking for. But if we're looking for solutions, it's going to be helpful to set this equation equal to 0. So I'm going to subtract over a 5 rad x. I'm going to add a 6. So our new equation is going to be x minus 5 rad x plus 6 equals 0. Now, we kind of have a quadratic, but not quite. Most quadratics would be x squared minus 5x plus 6, where here, we don't have that extra squared term. So we have x minus 5 rad x plus 6. But what we could do is factor it just like a quadratic. So let's think about it. What times what is going to give me x? Well, if I multiply rad x by rad x, I'm going to get x. Right? So right away, that's going to be my first term. So I'm going to FOIL, work backwards here. So if I have rad x, let me make it a little neater. Rad x and rad x. Well, when I FOIL it, do the first terms, x times rad x times rad x equals x. Excuse me. Now, we want to have two numbers that multiply together to be equal to 6, and they want to add up to -5. So I definitely want to have, two negatives because they have to be a positive, right? And they have to add up to a negative, so I definitely want negatives. And then, 2 times 3 is equal to 6, and if we combine those, they equal 5, so that's what I'm going to go with. All right, and I just want to double check this. minus 2 rad x minus 3 rad x. Perfect. So this is going to work. Now, just like any other quadratic, the solutions are where, we get that zero term. So what I want, on this side, we want rad x to be equal to 2. And on this side, we want rad x to be equal to 3. Okay? Now, since we're taking the square root of this x, in order to solve for it, just like the last problem, we want to square both sides. So on the left side, get x equals 4. Here we get x equals 3 squared is 9. So I'd have a solution set for this problem, 4, 9. Solution set, and I'm good to go. Most likely a multiple choice.